In this video we're going to look at friction. So friction is a force which opposes motion between two rough surfaces. So the force friction is always going to act in the direction opposite to the direction of the motion, or the direction that the motion would occur in if the frictional force wasn't present. So we're going to look at a couple of situations here. So this first situation, where we have an object resting on a horizontal surface and we've got the weight of that object acting down the way and the reaction force acting up the way. Now, since there's no horizontal force acting on this block at all, there is no frictional force because the block isn't going to move as a result of any force, because there isn't any force there. This second scenario, we've got a small horizontal force. This force I'm going to call T is pushing on our block, and the frictional force is going to move in the direction opposite to the direction that the force is travelling, which would have moved otherwise, and friction is opposing the motion in an equal and opposite direction, so as a result the block is not going to move. So with that just being a small force, that is not going to move. Now if we increase that force T being applied on the block, eventually we'll get to a point where the frictional force gets to a maximum level. So there is a maximum value for that frictional force, and if the force T here is greater than the maximum value that friction can take, then that is when our object will start to move. So as the force T increases, that frictional force will reach a maximum, and then when T becomes greater than that, that's when we're going to have our object moving, and our object is going to move in this direction because that's where the force is greater than our friction. So we were talking about the force having a maximum value, and the maximum value of that force is dependent on two things. It's dependent on the normal reaction between the two surfaces, so that reaction force is important, and also just how rough those two surfaces are. If we think about an object sliding on ice, for example, there's very little friction because of the smoothness of those surfaces, but then if we think about some other surfaces we may think of and be able to think of some which are more rough, so there's going to be a greater frictional force between those surfaces. So it's just depending on being a property of the surfaces themselves. And one way we can measure that is using something called the coefficient of friction. So the coefficient of friction, we use the Greek letter mu for the coefficient of friction. That is a measure of the roughness of two interacting surfaces. So that's just talking about the specific interaction between those surfaces. And the rougher the two surfaces, the larger the value of mu. So for smooth surfaces, we've got mu is equal to 0. And oftentimes when we're modelling with things like ice, one of the assumptions we make with that model is that mu is 0. In reality, there is a small amount of frictional force, but it would be something very close to being 0. And a couple of formulae for the value of friction. So F max is equal to mu r. So what this is saying is the maximum frictional force there can be is equal to the coefficient of friction multiplied by the reaction force. And sometimes we also see it as F being less than or equal to mu r. Now the reason this appears is because if the maximum force is mu r, if we consider the situations above again, the frictional force in this instance wasn't equal to mu r, it was less than mu r because there was no force acting on the object at all, so there was no frictional force. In this second example again, since the friction only opposes the motion and can't be any greater than the force acting forwards, it may not necessarily have been equal to mu r. It definitely would have been less than or equal to because the object wasn't moving. Only in this last example, where our force was greater than the friction, were we definitely certain that that F was equal to mu r, and even still the force going in this direction was greater, and that's what caused our object to move. So that is the maximum value of the frictional force, and this going to what I just said. If the force being applied is smaller than F max, then the frictional force will have the same magnitude as the force in the direction of motion. So it will oppose that motion, but it will have the same magnitude, the same size as the force which is travelling in the direction of motion. So we're going to look at a couple of examples of some questions involving calculations with friction. So we're told here a particle of mass 5 kilograms is pulled along a rough horizontal surface. If we're talking about rough surfaces, that's when we're being asked to consider the idea of friction. So if we're talking about smooth surfaces, friction doesn't apply. As soon as we've got surfaces which are rough, then that's when we're going to start to consider the idea of friction. So a rough horizontal surface by a horizontal force of magnitude 20 newtons. The coefficient of friction between the particle and the floor is 0.2, and we're being asked to calculate the magnitude of the frictional force and then the acceleration of the particle. So the first thing we're going to do, just going to draw a little diagram of that situation. So we've got our horizontal surface with our object of mass 5 kilograms. So since our mass is 5 kilograms, we are going to have a weight of 5g. There is going to be the reaction force R, and if I take this as being the direction of motion, a force of 20 newtons in the direction of motion, and it is being opposed by a frictional force between the object and the surface. So I'll put that there like this. And we were also told that the coefficient of friction was equal to 0.2. So that's the information that we've been given. So if we think about the reaction force, there's no acceleration in the upwards or downwards direction. Any acceleration is happening horizontally. So in that direction, I can resolve in the upwards direction, and I can say that the reaction is equal to 5g. So then our frictional force, F equals mu r, because our object is moving, we were told that it was being pulled along that surface by a horizontal force. So since it's moving, our frictional force is at its maximum. So F equals mu r, which is equal to, mu was 0.2, r was equal to 5g. So 0.2 times 5 would just be 1. So I've got 1 lot of g, which is equal to 9.8 newtons. So that is the magnitude of our frictional force. For the second part of that, we're being asked to find the acceleration of the particle. So given that the friction was equal to 9.8, we can resolve in the horizontal direction, and I can use F equals ma. Here I'm talking about force. I'm aware that there is an F for friction as well, so just be very careful. I'm talking force is mass times acceleration. This is the frictional force, which was 9.8. So my resultant force is going to be 20 subtract 9.8, and that is equal to the mass, which was 5, times the acceleration a that we were trying to find. So 20 subtract 9.8 is 10.2. So 5a is equal to 10.2. So I can divide through by 5 and get that a is equal to 2.04. So our acceleration is 2.04 meters per second squared. And that is our answer on that one. So our second example then, A particle of mass 2 kilograms is sliding down a rough slope that is inclined at 30 degrees to the horizontal. Given that the acceleration of the particle is 1 meter per second squared, find the coefficient of friction between the particle and the slope. So again, the first thing we're going to do, we're just going to draw a little diagram just to support with our understanding. So we've got our inclined plane, our rough slope with our angle of 30 degrees. We've got our object on the slope. Its mass was 2 kilograms. So it's G. We've got the reaction force R. I've got the frictional force opposing our motion, so I'll call that F. We've got that the acceleration, we're sliding down the slope, so we've got the acceleration, which we were told was 1 meter per second squared. That was our acceleration. So I'll put that our acceleration is 1 meter per second squared. And now I can also, since I've got an inclined plane, I can resolve those forces in directions which are perpendicular and parallel to the slope. So this one here, I am going to have that as being 2g cos 30, and for the opposite side it's going to be 2g sine 30. So if I think about finding an expression for my reaction force, so I can find that resolving in the direction which is perpendicular to my plane, I've got R being equal to 2g cos 30. Again, because our acceleration is only happening parallel to the plane, we don't have any acceleration in that perpendicular direction. If I now resolve in the direction which is parallel to the plane, I can use, since our acceleration is going that way, I'm going to use F equals ma. Again, F in this instance is talking about our resultant force. The resultant force is 2g sine theta minus F. So I've got 2g sine theta, so 2g sine 30 in this instance, the angle is 30 degrees. So 2g sine 30, subtract F is equal to the mass 2 times the acceleration. We were told that was equal to 1. So now we don't have the frictional force, but we know that F equals mu r. So I can use the fact that F equals mu r, and I'm just going to replace that F with mu r. So 2g sine 30 subtract mu r is equal to 2. Now sine 30 is a half. 2 times a half is going to be 1. So this here is just going to be 1 lot of g. So g is 9.8. So I can write that 9.8 minus, now we've worked out the reaction force was 2g cos 30. So I can substitute in for r here. So I've got 2g cos 30 multiplied by mu. So minus 2 mu g cos 30. So I've just multiplied that r by mu there is equal to 2. If I subtract my 2 from both sides and I add 2 mu g cos 30 just to get that onto the other side of our equals, so subtracting 2 is going to give me 7.8, and that is equal to 2 mu g cos 30. I can divide through by 2 to get rid of the 2 on this side, so dividing 7.8 by 2 is going to give me 3.9. So 3.9 is equal to mu g cos 30. And finally, to find mu, well, I can do 3.9 divided by g cos 30. And g, as we know, is 9.8. So I can just write that as 3.9 divided by 9.8 lots of cos 30, and again that's something we can put at this point, we can put into our calculator, and when we do, that is going to give us that mu was equal to 0.46 to a couple of decimal places. So that there tells us that the coefficient of friction between our object and the plane was equal to 0.46. That's the end of this video. Thank you so much for watching. For more A-Level and GCSE maths content, like and subscribe to N Jackson Maths on YouTube.